Folks, you remember we use double equals to check equality when using primitive variables. You know, like if n equal 4, something like that. That's just an example. We can technically use double equal with reference data if two variables point to the same reference. So I'll give you an example. Frog A equals new frog. Frog B equals new frog. So we've got two frogs. And then if we say A equals B on this line here, then if we said system.out.println A equal B, we'd get a true. Because you remember when we do non-primitive data is one way to say it. Another way to say it is reference data or class data. It's everything from strings to frogs to book, any custom class we make. It's called reference. They're called reference variables. What they are is they store a memory location that points to where the actual data is. So when we say frog A equals new frog, Java allocates a little space in memory, however much it needs to hold all the information a frog might ever hold, and then back in the where it says variable A, it just points to that memory location. So what we're doing here, frog A, we make a frog in memory, and we have a variable that has the memory location. Frog B, we make a different memory variable, location in memory, and a different variable B. And then when I say A equals B, it basically just eliminated the A1. The A1's gone now, and now we have two variables that both point to the same memory location. So if we use double equals here, it actually would say true, just because both variables are pointing at the same memory location, so they literally are exactly the same. Okay, but that's kind of obscure. Most of the time, if you want to see if two things are, if you want to see if two reference variables are the same, you have to use dot equals. This is, for example, with strings. That's where we've used it so far. I want to back up. I realized I had a second example here, which was if I just said frog A equals new frog, frog B equals new frog, and then I said system.out.println A equals B, this would give us false. Because A points to one location in memory, B points to another location in memory. They're different frogs. It's not the same. It's just that obscure place where we took the A and said A equals B, that it would actually print true. But back to this point. Most of the time, if you want to see if two reference variables or class variables or non-primitive variables, I'm talking about the same thing, are the same, you have to use dot equals. Strings are somewhat of an exception, but you can't count on it. So when you have, like, sometimes you guys have written your programs and it seems to be working, but you're doing equal when you're checking strings, you'd get points taken off on the AP test. So just learn to use dot equals when it's a string and double equals when it's primitive. So here's the deal. Dot equals is defined in the class, in the capital O object class. All classes are children of the object class. So there's this class that we haven't even been talking about that's above all of them. Java's designed that way, so there's some things in the object class that you have available to anything. I want you to take a second open a browser, and we're going to Google and look at the object class. So I'm going to open up a browser, and I want to use the Google and say Java object class API. So Java object class API. API stands for Application Programming Interface. If you hit enter, then we want to choose this one. I think we're using Java 7, but this is the one we're going to look at. And then Java says, hey, I'll show you what's up with the object. It's a class called object. It's been around since the very beginning. Has one constructor. But here's where it matters. There aren't a lot of things here, and we don't have to understand them all by a long shot. But there's this thing called clone. I don't know what that is. But here's dot equals. It indicates whether some other object is equal to this one. And look, we'll skip down to toString. See here where it says toString? We can click on, let's click on toString first. It pops you down here. So it returns a string representation of the object. In general, the toString method returns a string that textually represents the object. And so for object, it returns the name of the class. It does get class, get name, and then it puts an @ symbol, and then it does the memory location. Or whatever, this thing called a hash code. It doesn't really matter to us what it is. You know how sometimes you're printing something out, you're like, Mr. Days, my frogs are printing out as frog at, and then weird characters. That's what's going on. This is the default toString. Otherwise, Java would say, I can't print that because there's nothing to print. But every object has a toString because it exists up here in object.
This is coding heaven.
Yeah, way at the top. So then let's look at dot equals. So somehow get to dot equals on this page. I don't know why it jumped to the top here, but here we are, dot equals. It indicates whether some object is equal to another object. Here's the thing. With things like a piece of text, it's obvious, right? If the characters are the same, then it would be equal. But let's say you take this class that I've made you work with for months now called frog. What would make two frogs be equal?
Location?
Yeah. You remember there's a location variable. So what we could do in frog is write code that would we'd have a dot equals. We'd override the object class dot equals and do a quick check and say, hey, is the location of this frog equal to the location of that frog? Yeah, okay. Then they're equal. Otherwise, not. Like it's a Boolean. It returns true or false. So anyway, I just wanted you to see this. And the two methods that we care about in the object class are dot equals and toString. I don't want to lie though. Let me look. I think there might be one more. Nope. Just those two. And why do we care about them? We care about them because we will override them often. We care because we often override these methods. Right? We want a toString that works. Like for our frog, it currently prints a bunch of symbols and then a number at the end, so it tells you where the frog is. That's better than a memory location. You know, who cares about, frog at something. All right, so if you have a custom class, you know, like book or frog or all the different things we've been creating, and you want to be able to check equality, you have to override dot equals. And as I said, normally in a dot equals, you just check all the specific class variables, and if they're all the same, you would say true, and if they're not the same, you would say false. And so I've been talking about the frog. Guess what? I wrote a dot equals for the frog. So go ahead and get day 66 example 1 off my website, please. So back here, day 66 example 1, and there is only one example today in case that felt ominous. Open it up and you'll see our friendly frog that we've been working with for a long time. So we got, each frog has a private variable called location and a hop command, a get location command, a toString, and with today's version I threw in a dot equals. So check it out. This is how a dot equals needs to be written. And you can, there's some flexibility here, but this is what I want you to do. So first, it has to accept a generic object as the parameter passed in. You might think, why we don't put frog f or something here? And that's because we want to override dot equals that's in the object parent, and this is the way the object class does it. So even for a frog, if we did a frog f instead of object obj, what we'd be doing is we'd be overloading the method. There would still be the parent one with the object. It'd be a little confusing. So I'm asking you to do 4 things here, and I'll write them down in a second for the notes. First, check if the parameter is null. So if object equal null, return false. That means they're not the same frog. And then if dot get class, see there's a not here. If the classes are not the same, this prevents a crash. We won't try to access a variable that doesn't exist. So we're saying, hey, if this class is not equal to that class, we haven't used that command before, but it returns frog, a piece of text. It tells you what class this is. So we're making sure, first we're making sure one of the passed in one is not null. Second, we're making sure that the passed in one is the same class as the one we're comparing it to. Then we convert the generic one into a frog. That's because we're in the frog class. So we say frog, I'm making a new frog basically. Frog other equals, and then we're casting the generic object into a frog now. And then we can check the variables. See where we say other dot location equal this dot location. Technically you don't need the this. You can just refer to the variable. It's right here, this one. But I put the word this there because it's helpful, so you keep your bearings. We've got the one that's in the one called other, and we've got the one that's in the current object. And if for a frog, all we care about is if the location is the same, we're going to say the frogs are the same. So let's go back up to the top. Let's run this. We should get true, right? Because a brand new frog, they're at the same location, which is location 0. So you can run this. You don't have to just watch. I tell you, the more that you get your hands on it and play with it, the better off you'll be. So see, it says true. They're equal. And now watch me say a.hop 1. I'm going to make just the first frog hop once. And we should get false. Right? They're not the same anymore. For another test here, I could say null. We're going to send over null. It's not the same. I could put a string in here, a new string. I'm just testing all our different parameter permutations. If I send over something that's not a frog, see our code handles that. It says, no, it's not a frog. But we go back to B. So this would be false because A hopped once, B didn't hop. But check it out. If we hop B now, they'll be true. It'll be true again because they're the same, inching their way forward. Yeah, Ian.
What if both frogs are null?
I think that if you try calling dot equals on where the one you're calling it on is null, it might crash. I'm not sure. Yeah, we're not going to handle that though. I think if I said frog A right here and didn't hop, and tried to do a equals b, I think the compiler wouldn't even let me do this. Yeah, it says variable might not be initialized. So I don't know if I can say null here. Yeah, null can't be dereferenced. So whatever that means, but you can't. I'm sure we could code it so that this happened, but I think it would crash. So we're assuming that the left hand of the dot equals is an actual instantiated object. I mean, you've used the new command, it's been created. So back to our notes. I'd like to see 4 parts to a dot equals that you write for me. 1, check if obj is null. 2, if it is, return false. 2, check if, we don't have to say check if, make sure obj and current object are the same class type. How do you do that? Well, it's in the example I gave you, so I'm just counting on you to refer to that. You could go to the example and copy that perfectly formed frog dot equals and paste it into your notes if you want. That would be a good thing to do. Then we cast obj to current class type, and then we check local variables, the private variables. If all are the same, return true, otherwise false. In the case of the frog class, there's only one instance variable. It's the location, so you only just check one thing. But if there's other things, like let's say you were comparing 2 student objects, you'd have first name and last name, and maybe grade level or GPA, and you could do one if statement. Or you could even just say return this equals that, and this equals that, and that equals that. So that if any of the things were false, it would return false. So I would copy this out of the example frog class and put it all into your notes, because you want to be able to refer to this. Oop. I'm going to put that note. Sure. Copy out. You want to have that frog class dot equals code in your notes. It's not that bad. Let's review it again. We're checking if the one sent over is null. If it is, we return false. We're checking that the 2 classes are the same type of class. Otherwise, there'd be no point in trying to check anything further. So we return false. And then we cast the sent in object that was a generic parent object type. We're casting it to be a frog. And the name of it could be anything. It could be Hayes the frog, but then you have to use Hayes the frog here. You see what I'm saying? I just called it other so we could keep track. Like there's the one that has the one that has this right here. That's the one to the left of the dot equals. Anyway, and then if all the local variables are the same, you can return true. Another way to write this last thing is literally, you could say return and then paste the condition that matters, and Java will return true or false depending on whether that condition is true or false. But I was trying to make it really clear. If other location equals this location, return true, otherwise return false. So questions? That's the